Okay, we're on lesson 21 of the pre-calculus, and what lesson 21 is adding, subtracting, multiplying, and dividing with rational algebraic expressions and equations, which means we're dealing with fractions with algebra. Okay? Now, if we go back in our mind to the very first day of school in Algebra 1, Lesson 1, Rule 1, Page 1, we would always say, I would highlight the operation, and I would say, what's the operation, what's the rule for that? And we started doing what we call brain training a long time ago. So here, if we follow that, we would say, what is the operation? And the operation is addition, and then we would say, well, what's the rule for that? To add or subtract. The names have to be the same. In algebra, we call them like terms. With fractions, we say that we need a common denominator because the common denominator is that same name. So to add or subtract, the names have to be the same. In algebra, we call them like terms. With fractions, we say that we need a common denominator. So we have to get a common denominator. And to do that, we generally align things vertically. But we need to find that common denominator. And then if we scrolled over to page 5 in the algebra book, we would learn how to multiply. And then we go to page 8, and it shows us how to add fractions that do not have the same denominator. So if you went to page 8, it would say you need to find a common denominator, and the common denominator is the least common multiple. And to find the least common multiple, you're going to do the prime factorization and write them exponentially, and then you take the largest power of each prime and multiply. It says that on page 8 of this textbook. Take the largest power of each prime and multiply. So if you need to refer back to that, you can. So we're going to need to write out all of the factors of 54 m n to the fourth. And we're going to need to write out all of the factors of 36 m cubed n. So to do that, we need to do the prime factorization of the numerical part. So we'll take the 54 divided by 2 is 27, divided by 3 is 9, divided by 3 is 3. So we do the prime factorization, and then we're going to write it exponentially. Exponentially, that's 2 to the first power times 3 to the 1, 2, 3. 3 to the third power times, now we need to throw in our variables, m to the first times n to the fourth. So 54 m n to the fourth, written as the product of its factors exponentially, is 2 to the first times 3 to the third times m to the first times n to the fourth. Understand that? Okay. And then we need to break down the 36. 36 divided by 2 is 18. Divided by 2 is 9. Divided by 3 is 3. So 36 m cubed n, written as the product of its primes exponentially, is 2 to the second times 3 to the second. 2 2's and 2 3's. And then m to the third and n to the first. So we wrote out each of those original denominators as the product of their primes exponentially. I'll let everybody catch it. What do you do now? Take the largest power of each n, multiply. So, of the 2's, what was the largest power of 2? To the second. Of the 3's, what was the largest power of 3? To the third. Of the m's, what was the largest power of m? To the third. Of the n's, what was the largest power of n? To the fourth. You take the largest power of each and multiply. 2 squared is 4. 3 cubed is 27. 4 times 27 is 108. 108. M cubed n to the fourth. That's my common denominator. 108 m to the third n to the fourth. 108 m to the third n to the fourth. They understand so far? Now it's time to make. It's time to make equivalent fractions. We're going to make equivalent fractions. To make equivalent fractions, we say O denominator times what gives us new denominator. So we think 54 times what will give us the 108. 2. And then we go to our, I'll put my 2. And then we're going to go to our m's. We've got an m to the first, and we need to get to an m to the third. M to the first times what is m to the third? M to the second, because when you multiply with like bases, you add the exponents. 1 plus 2 is 3. What about the n's? I've got 4. I'm trying to get to 4. I do not need any more. Sounds like a cat in the hat thing. I don't know if I'm supposed to say that when I'm recording. Anyway. And so we're going to multiply the numerator by 2m squared, right? And it gives us a new numerator of 10m squared. Same on the bottom. We think 36m cubed n times what will give us my new denominator. So 36 times what's 108? 3. And then m cubed, I've already got it. I've got an n to the first, and I need to get to the fourth, so I need an n to the third. So I multiply the numerator by 3n to the third to get my new numerator. We're making equivalent fractions. That's proper terminology. So 3 times 3n cubed is 9n cubed. So we got that. It's cubed because you already had 1 here, and you're trying to get to 4, so you needed 3 more to get to 4. Okay. Now we're going to add these, right? To add, what has to happen? What happens to be true? The names have to be the same. They are. So when you add, what happens to the name? It stays the same. And so we add the numerators. The numerators were 10m squared and positive because of plus 9n to the third. Those are not like terms, so that becomes my numerator, 10m squared plus 9n to the third over the common denominator of 108m cubed n to the fourth. Any questions on number 1? So whatever you can do with numbers, you can do with variables. You just have to follow the same set of rules and then apply your exponential law as you go. Any questions on number 1? Okay. Pretty good. Number 2. Number 2, we go back to the first day of school in Algebra 1 and we say, what is the operation and what is the rule for that? Well, the operation is addition. To add or subtract what has to be true, the names have to be the same. In algebra, we call them like terms. With fractions, we say that we need a common denominator, and the common denominator will be the least common multiple. And to find the least common multiple, you do the prime factorization if there's numbers. If not, you do the factorization, and you write those factors exponentially. So we're still going to factor and write it exponentially. Well, these are quadratics, but we learned how to factor quadratics. On this particular quadratic, there's an a of 1. If there's an a of 1, then we know we don't have to use the whole AC method to factor. We can go ahead and put in our x's, and we can ask a question, and the question is, what can I multiply to get my C value and add to get my B value, right? What two numbers can you multiply to get a positive 25, but yet add to get a negative 10? Negative 5 and negative 5. So I get an x minus 5. I'm going to have to rewrite that. I'm going to get an x minus 5 and an x minus 5. But how do you write that exponentially? X minus 5 squared. Because we have to write them exponentially. And then my second denominator was x squared minus 25, which is the difference between two squares, and the difference between two squares factors into binomial conjugates x plus 5x minus 5. So we need to remember all of our factoring rules. And we want those to be written exponentially, so that's to the first and to the first. So we found the factors of the denominators and wrote them exponentially. Our rules aren't changing any. Now we take the largest power of each. Of the x minus 5s, what's the largest power? The second. Of the x plus 5s, what's the largest power? The first. So we take the largest power of each factor and multiply. Rules are the same. Understand what we're doing? We found the factors. We wrote them exponentially. We took the largest power of each factor, and now we're going to multiply. Now, if we multiply, we could go ahead and re-expand that first as x squared minus 10x plus 25 times x plus 5. And we'll send the x through, and then we'll send the 5 through, right? So when we send the x through, we're going to have x times x squared is x cubed. X times negative 10x is negative 10x squared. X times 25 is 25x. Now we're going to send the 5 through. 5 times x squared is 5x squared. 5 times negative 10x is negative 50x. 5 times 25 is 125. And then we're going to combine our like terms. X cubed minus 5x squared minus 25x plus 125. So there's my common denominator all multiplied out. x cubed minus 5x squared minus 25x plus 125. Sorry, that got crazy over there. So x cubed minus 5x squared minus 25x plus 125 is my common denominator. The question was, how did we get all this junk? And what we did is we took this x and we distributed it through there. So we had x times x squared, is that x cubed? X times negative 10x is negative 10x squared. So we multiplied the x through, then we multiplied the 5 through, and then we combined all our like terms. Yeah, we added the red and the black. So the negative 10x squared and the positive 5x squared gave that. The positive 25x and the minus 50x gave us that. So we combined all those like terms. Yeah. You understand everything now? Okay. So now it's time to do what? Make equivalent fractions. So we have to think this times what will give me that? Well, this was what? Part of my common denominator. Let me highlight for just a second so we don't get lost. There's a lot of stuff over there. My common denominator came from these things being multiplied, right? We took the largest power of each and multiplied. So this big old yucky looking denominator is really that, okay? Now, this part right here was what? It's that. So if I want to think this times what is going to give me this, well, I'm really thinking, well, this is the x minus 5 squared part, right? So what's the other part? X plus 5. See how you can find it there? So I need to multiply the numerator by x plus 5. That was weird. Y'all see how we found the other factor? And then when we look down here, we're saying, okay, I need to think this times what? Well, the x squared minus 25 was an x plus 5 and an x minus 5. It was the x plus 5, but it was only one of those, right? It was this, but it was only one of the x minus 5s, so that leaves me with the other x minus 5. So I'll multiply the numerator by x minus 5. Any questions? Did we follow all of that? So we're going to distribute here and have 5x plus 25. We're going to distribute here and have 7x minus 35. So we made equivalent fractions. Now we can add. The result will have the same name, the common denominator. We can combine like terms in our numerators. 5x and 7x is 12x. 25 and negative 35 is negative 10. So we get 12x minus 10 over x cubed minus 5x squared minus 25x plus 125. And that is the result of adding those. Any questions on that? I'm going to make that x cubed plainer since it's in the video. Okay. So that's just plain old addition, like fourth grade fractions, right? No, maybe a little harder. Fifth grade fractions, sixth grade. Yeah, a little bit harder, but same. The idea is the same. It never has changed, right? Need a common denominator. To find the common denominator, you find the least common multiple. To find the least common multiple, you find the factors and write them exponentially. You take the largest power of each factor and multiply. You then make equivalent fractions, combine the numerators, keep the denominator the same. Got it. Any questions on the first two? All right, that was page 230 in the Algebra 1 textbook. 230. Now, notice that what we had here was what? It was an expression. It didn't say equals something out here, right? It was an expression, and we simplified the expression by combining like terms. You understand that? Combine like terms. The next problem is an equation, not an expression, and we want to solve that equation, so we have a different set of rules. So scroll on over in your books, if you have them open, your algebra book to 232. 232. I'm assuming that's the right page. It says solving rational algebraic equations involving addition and subtraction, right? And then it's got steps. Step 1, it said to do what? Find the common denominator. Step 2, multiply through by that common denominator. That's going to eliminate all the denominators, so there's not any fractions anymore. And then you're going to solve by whatever method is going to just, it's going to be visual what you need to do from there. Okay? So we need to find a common denominator between all of the denominators, and then we need to multiply every term by that common denominator to eliminate all the denominators. So the common denominator is the least common multiple. Now, what you have to realize is that this is like x minus 5 in parentheses because it's the denominator of a fraction. And this is like x plus 2. So it's pretty obvious that the x minus 5, written exponentially, is x minus 5 to the first power. And it's obvious to us that x plus 2, written exponentially, is x plus 2 to the first power. But we need to rethink this quadratic as being the product of two factors. And we know that if a is 1, we can just go ahead and stick an x there. And we can think, what can I multiply to get negative 10, but add to get negative 3? And the answer is going to be negative 5 and positive 2 in any order you want to put them. So we should be able, at this point in our mathematical career, be able to quickly factor with leading coefficients of 1. Exponentially then, x squared minus 3x minus 10 is x minus 5 to the first power times x plus 2 to the first power. And so we wrote them as the product of their factors exponentially. The least common multiple is each factor to the largest power represented. The factor of x minus 5, what is its largest power? Well, it's 1 both times, so the largest power represented is a 1. And on the x plus 2, the largest power represented each time is a 1, so the largest power is a 1. Now, if we wanted to write out the common denominator pretty, we could multiply those, but we really want to see factors that are canceled. And if you multiply it, you can't see the factors anymore. So we're going to leave it like that when we multiply through by the common denominator so that we can see cancellation opportunities. Okay? So here's my common denominator written as its factors. We're going to multiply every term by that common denominator. Every term on both sides. And by leaving it written as factors, we can see the cancellation opportunities that we wanted to see so that we make the denominators go away. Okay? But I understand what we're doing so far. So my cancellation opportunities are that in the first one, the x minus 5's cancel. In the second one, the x minus 2's cancel. And in the third one, they both cancel. Which leaves me with a 1 times an x plus 2 in the first situation, plus a 3 times x minus 5, which will distribute as 3x minus 15, if we want to go ahead and do it. And on the other side, it's just a plain old 31. So by multiplying through by the common denominator, we eliminated all the denominators. And now it's obvious to us that there's only one variable x, and we can just start using the order of operations to simplify and solve. Our first move then would be to combine like terms. So we're going to have x plus 3x is 4x. 2 minus 15 is negative 13 is equal to 31. There's nothing else we can do to simplify. The variable's not on both sides. We have multiplication and subtraction, and we're going to undo subtraction first by addition, and we get 4x equal 44. We undo multiplication by division, and we get x equal 11. Any questions on that? Now, just for the fun of it, on one of these, let's just play with that and see if it really works. If we plugged in an 11 here, and here, and here, and here, we would have 1 over 11 minus 5, which is 6, plus 3 over 11 plus 2, which is 3/13, is equal to 31 over 11 square minus, so that'd be, somebody punch that out right quick. 11 squared is 121 minus 33 minus 10. What would you get? 121 minus 43. So you get what? 68. Yeah, 78. Yeah. Now, look at this. What is the common denominator between 6 and 13? 78. So this would be times 13. This would be times 6. So it checks out, right? So we did find the value of x that would make that true, which is kind of cool. Any questions on number 3? That would have been hard to do without some algebra trick going on, right? Just what number is that? Try it till you get it. That could be kind of nasty to try it until you get it. Okay? All right. Any questions so far? All right. Number 4. Number 4, what does x squared minus 36 factor into? That's x squared minus 6 squared. It's the difference between two squares. The difference between two squares factors into x plus 6 and x minus 6. Right? And then this is what you see, and this is what you see. So as far as the least common multiple, we've got x plus 6 first times x minus 6 to the first with our first denominator. With our second denominator, we have x plus 6 to the first. And with our third denominator, we have x minus 6 to the first. Right? So the largest power of x plus 6 is to the first, and the largest power of x minus 6 is to the first, and so our common denominator is x plus 6 to the first times x minus 6 to the first. And we would normally multiply them out if we actually wanted to see the common denominator, but we're trying to get rid of the thing. So we want to leave it as factors so we can see cancellation opportunities. Understand that? So we're going to multiply every term of the problem by the common denominator between all of the denominators in the problem. Leaving it written as factors so that we can see cancellation opportunities. In the first one, I can cancel both of them. On the second one, I can cancel the x plus 6. On the third one, I can cancel the x minus 6. On the first one, I'm left with a 70. On the second one, I'm going to be distributing a negative 28 through an x minus 6, right? Don't forget that minus as a sign. That'll hide from you there. So we get negative 28 times x is negative 28x, and negative 28 times negative 6 is positive 168. And then over here, we're going to distribute a 1 through an x plus 6 and get an x plus 6. So by multiplying through by the common denominator, we eliminated all of the denominators. We only have one name x, so we can solve using the order of operations. And so we say, is there anything that we can do to simplify and we can combine like terms? So we get negative 28x plus 238 is equal to x plus 6. There's nothing else we can do to simplify, and so what do you do next? You get the variable you're isolating on, one side of the equal sign, remembering to change the sign when you cross over, right? Anything we can do to simplify. Get the variable on one side, undo. So we have negative 29x plus 238 is equal to 6. We've done all we can do to simplify. We got the variable we're isolating on one side. Now it's time to undo. We're going to undo addition by subtraction. We're going to have negative 29x is equal to negative 232. Now we're going to undo multiplication by division. When you divide with the same sign, the answer is positive. Does it divide evenly? 8. And so we get x equal 8, which we could plug in and check, and it would come out true. Any questions so far? So the first two problems, we were adding rational algebraic equation terms. So we had an expression that we were simplifying. And then the next 2, 3, and 4, we had a rational algebraic equation involving addition and subtraction. And to simplify that, or to solve that, we used 3 steps. Number 1, we found a common denominator. 2, we multiplied through by that common denominator, which eliminated the denominators. And then 3, we solved by the method that we could obviously see to solve by at that point. The next little section will be solving rational algebraic equations involving multiplication and division, and we'll have to wait on another video to get that done. Any questions on what we covered so far today? All right, appreciate your attention.